All right, let's look at the practice exam 3, problem number 7. All right, let's look at part A. So we want to interpret this as the area of a certain region to find the value of this definite integral. All right, so let's do that. All right, so look at the function. So y equals absolute value x minus 1. Let's sketch the picture. All right, so y equals absolute value of x minus 1, right? But we know how to sketch the graph of absolute value of x, so that's a V-shaped graph. So let's start with that, right? So this would be a V-shaped graph. So this is the graph of y equals absolute value of x, right? The only difference is that there is going to be, so this guy right here, right? This is the shift, the horizontal shift to the right 1 unit. So this guy shifts to the right 1 unit, right? So we just have to shift this guy. So this is 0, 0 right there. We just have to shift it to the right 1 unit. So this is going to be 1 right here. And then the graph is going to be, so it's still got the V shape. So it's going to look like that. And then it's going to look like that. All right. And the region goes from 0 to 3. So start from here. And 1, 2, and 3. So 3, so it's going to be up to here. All right. So the region we're looking at would be this small triangular region, right, combined with this triangular region right here, right? I'm gonna call the first guy, so little guy A1, and I call this guy A2. All right. So this is going to be simply the combination of A1 and A2. Right? So let's find the area. Right? So since it's a triangular region, formula for the area of a triangle is 1/2 base times height. So for A1, it's going to be 1/2. Right? Base is 1, so this is base 1. Right? And height is going to be actually 1 too. So this is 1. Right? So base times height. So 1/2 times 1 times 1. Plus, right, this guy, that right here, the value is, you can plug in 3 minus 1 is 2, so with the absolute value, so this is 2 right here, right? So it's going to be 1/2, right? Base is going to be 1 from 3, so it's 2. And the height is 2 as well, right? So this is going to be, A1 is just 1/2. Right, A2 would be 2 and 2 cancel out, so it's going to be 2. Right, so 1/2 plus 2 would be 2 is 4 over 2, so 5 over 2. Right, so the value of the definite integral is 5/2. All right, let's look at the part B. All right, part B, this is actually a top semicircle with radius 3 because here 9 is 3 squared, right? So let's draw a picture. So you have, here's the x-axis, right? And here is my y-axis, right? And here's the origin, right? So the radius is 3, so it's going to go through -3 here, and a +3 on the y-axis, and a +3 on the x-axis. So I try my best to draw a nice looking semicircle, All right, so it's gonna look kind of like that. All right. Then the region starts from -3 and ends at 0. So we are looking at from this region right here. So -3 all the way to 0. So just up to here, up to the y-axis, right? So we are looking at the quarter disk, right? So we just have to find the area of that, right? So this is going to be, right, since it's just a quarter disk, so it's going to be 1/4, right? Then area of the whole disk would be pi r squared. So it's going to be pi r, in this case, radius is 3. So 3 squared, which is going to be 3 squared is 9/4. And then you have a pi, right? So it's a 9/4 pi is the value of this definite integral, right? That's it. I hope that this was clear.